Alright, so for this lesson we're going to be going over atomic structure and theory. So just as a quick refresher from Science 10, atomic theory states that all matter is composed of atoms, and atoms of the same element are the same, whereas atoms of different elements are going to be different. And atoms combine in whole number ratios in order to form compounds here. Okay. Now, the key thing with atoms of the same element is that each atom of the same element is going to have the exact same number of protons. Okay, that's forever and always going to be true. It's the amount of protons that helps to identify what element you're talking about. Okay, now what exactly is a proton? A proton is part of our subatomic particles that make up atoms. Okay, so atoms contain 3 subatomic particles. So the first one we just talked about, that's protons. Okay, the next one is going to be electrons, and then the last one, or the last subatomic particle that makes up an atom, is going to be a neutron. Okay. So first, in this table off to the side here, we're going to be talking about protons. So the symbol for a proton is going to be P with a superscript plus sign there. And where protons are located are in the nucleus. Okay, and it's going to have a positive 1 charge or a plus charge. Okay. Neutrons, those are also in the nucleus. But as the name would kind of hint at, these neutrons, they're going to be neutrally charged, so they have a 0 charge or neutral charge. Okay, and protons and neutrons are going to make up most of the mass of an atom. The third subatomic particle in this chart here, that's going to be electrons. Oh, and I realize the symbol for a neutron would be N with a little O as a superscript, and for electrons it's E with a little negative sign there. So electrons, those are located outside the nucleus. And those are going to have a negative charge. Okay, or each electron has a negative 1 charge. Okay, so as you can see in this diagram off to the left here, the nucleus is at the center of each atom, and it's made up of protons as well as neutrons. Now electrons, those are going to be outside of the nucleus. So electrons can be here, here, here in this diagram that we're shown here. Okay, so electrons are circling around the nucleus. Now, we need to figure out a way of how do we know how many protons, neutrons, and electrons each element or an atom of each element has. And in order to do that, we're going to have to look at our periodic table. So in this diagram, they have selected sodium to examine here. And now there's a couple of important pieces of information that we need to be aware of. So the number in the top left-hand corner of each box that represents an element, that's going to be called the atomic number. And what this represents is the number of protons. Okay, so if I go to my periodic table, okay, and if I look at sodium, which is right here, so there's the atomic number 11. So that tells us, okay, every atom of sodium is going to have 11 protons. If we look at something like scandium, every atom of scandium is going to have 21 protons, and so on and so forth for the rest of the elements there. Now, there's another number on the periodic table for each element that we do need to pay attention to in order to determine how many subatomic particles we have here. So the atomic mass is going to be the number. It's usually right underneath the symbol for each element. And what this represents is the number of protons and neutrons in an atom. Okay. So why is this useful? So essentially, as long as you know the atomic number and atomic mass, you'll be able to subtract the two in order to figure out the amount of neutrons for each atom of an element. Okay, so the reason this works out is because the atomic number represents how many protons. Okay, and if you subtract the amount of protons from the atomic mass, that's how you're getting the neutrons. Okay, so the atomic number for sodium is 11. So this means that sodium's atoms have 11 protons. So again, atomic number is the amount of protons you have. Okay, and if we are talking about an atom of a particular element, then the amount of protons for atoms, I should say, because this is going to change once we talk about ions, the amount of protons is going to be equal to the amount of electrons. So sodium atoms have 11 protons as well as 11 electrons. Now, the reason why for atoms there is the same amount of protons and electrons is because atoms are neutrally charged. So we want the same amount of positive charge as negatively charged subatomic particles. Okay, so very important that you know what atomic number and atomic mass represent. Okay, so the number of protons determines the element. The number of protons for an element is never going to change. Okay, so for example, any atom of carbon is going to have 6 protons. So if you want to look at your periodic table, if we look at carbon here, we can see its atomic number is 6. So that's why it's going to have 6 protons. Okay. Now, as stated previously, the amount of electrons is going to be equal to the amount of protons, but this is for atoms only. It does not hold true for when we talk about ions. What ions are essentially atoms that have a charge. Okay. Now, neutrons are going to equal the atomic mass, which is rounded to the nearest whole number, minus the atomic number. Okay, so super crucial that you round the atomic mass to the nearest whole number because you can't have a fractional amount of neutrons. You can only have whole numbers of neutrons. Okay, another way to say what I'm saying is the number of neutrons plus the number of protons is going to be equal to the rounded value of atomic mass. Okay, so every atom has the same amount of protons and electrons. Specifically, we're talking about atoms. We are not talking about ions, which is because we have the same amount of protons and electrons, it makes atoms neutral. Okay, so if we were to figure out how many neutrons sodium has using what we've been saying here, okay, so neutrons is going to be equal to the atomic mass subtracted by the atomic number. So if we did this for sodium, okay, first off, we're going to take the atomic mass, that 22.99, and we're going to round it to the nearest whole number. So that's going to be 23. and we're going to subtract it by the atomic number, which is 11. So then we get that sodium has 12 neutrons. Okay. And you can do this for every element that you see in your periodic table. So for example, if we did carbon and we were trying to figure out how many neutrons an atom of carbon has, we would take our atomic mass, round it to the nearest whole number, so that would be 12, subtract the atomic number, 6. Well, 12 minus 6, that's going to be 6 neutrons. Okay, so on and so forth there. If I was doing chlorine, or finding out how many neutrons are in chlorine or are in an atom of chlorine, I would go 35, because that's the atomic mass, subtracted by the atomic number, which would give us 18 neutrons. Okay, so just some more examples to help you out there. So down below here, there are practice problems. Please refer to the lesson guide to see which of them are assigned. Now, why do we need to know the subatomic particles for each atom? It's because we need to know what an atom consists of so that we can draw Bohr energy level diagrams. So what this is a model of an atom or an ion, although we're going to start out with drawing atoms, okay? And this model of an atom shows that electrons are arranged in energy levels, or they're also called orbits, around the nucleus. So Bohr's energy level diagrams state that electrons are arranged as follows. So what this means is that there can only be a certain amount of electrons in each energy level. And how many electrons are used to fill each energy level corresponds to how our periodic table is arranged. So I'm going to get rid of this here and clean this up a little bit. So if we look at the first row of the periodic table, okay, so the first row, or each row, sorry, of the periodic table is called a period. Okay, so if we look at the first period of the periodic table, we notice that there are 2 elements in the first period. Okay. The maximum amount of electrons that can go in the first energy level is 2. So let's write that. So these are important numbers to know, but why I'm showing you the periodic table is so that you don't necessarily have to memorize each number. If we look at the second period of the periodic table, you can count up that there's 8 elements total in the second row, or the second period of the periodic table. Okay, so correlating this to how many maximum electrons can fit in that second energy level, we can fit a maximum of 8 electrons in the second energy level. And with the third row, or the third period, let's get rid of that. Once again, there are 8 elements. So that means we can fit a maximum of 8 electrons in the third energy level. Okay, so these numbers are very important for helping you to draw Bohr energy level diagrams. Okay. So the electrons in the outermost shell of a Bohr energy level diagram, they have a special name. Okay? These are called valence electrons. Now, why would we give a special name to electrons that are just in the outermost shell or outermost energy level? Okay, so in this diagram off to the right here, the valence electrons, there's 2 of them. Okay, and the reason why they have a special name is because these are going to be the electrons that are going to do or create bonds between different atoms. Okay, so they're the only electrons that are going to do something interesting, so that's why they get the fancy name. So the number of energy levels with electrons is going to be equal to the period number for that atom. So remember, going back to the periodic table, remember that each row is called a period. Okay, so what they're saying is, let's say we were trying to draw magnesium. Okay, because it's in the 3rd row, we would be drawing 3 energy levels for magnesium. Okay, and now the number of valence electrons, so the electrons in the outermost shell, is going to be equal to the last number or the last digit of the group number. So what is the group number? The group number corresponds to like each column in the periodic table. So hydrogen, lithium, sodium, potassium, rubidium, so on and so forth. All of those elements are in group 1. So all of those elements are going to have 1 valence electron in their Bohr energy level diagram. Going over to group 2, all of these elements, beryllium, magnesium, calcium, so on and so forth, they're all going to have 2 electrons, 2 valence electrons, in their outermost shell. Now, if we move to the other side of the periodic table, this is why I said the last digit of the group number. So boron, aluminum, gallium, anything in group 13, those are going to have 3 valence electrons. Carbon, silicon, germanium, anything in group 14, those are going to have 4 valence electrons. Okay, group 15 is going to have 5 valence electrons. Group 16 is going to have 6 valence electrons. Group 17 is going to have 7 valence electrons. And group 18 elements are going to have 8 valence electrons in their Bohr energy level diagrams. Okay, so that's just more information how you can use the periodic table to help you draw these energy level diagrams. And again, an example of one way to draw an energy level diagram is right here. The only thing that's missing is a little circle around the protons and neutrons to mean like that's the nucleus. Okay, so sketching Bohr atom diagrams. So this is specifically talking about atoms, so that means the amount of protons are going to be the exact same amount as electrons. Okay, so first off, we're going to use a periodic table and determine the number of protons, neutrons, and electrons of the atom. We're going to place the protons and neutrons in the nucleus, and we're going to represent, there's 2 ways you can represent electrons. You can either use dots or numbers. And you'd write it, if you're using the numbers, you'd write it as like however many numbers and then electrons to represent the electrons. Okay, and we're going to draw in the electrons according to the energy levels. So that goes back to how many electrons can fit in each energy level. Okay. So again, the first orbit or energy level means the same thing, can hold at most 2 electrons. The second orbit can hold at most 8 electrons, which is called the octet rule, okay, that they hold 8 electrons. And then the third orbit can hold at most 8 electrons, and once again that's an application of the octet rule, which just states that in order for an atom to be stable, it has to have 8 electrons in its valence shell. So for example here, we're going to draw Bohr diagrams for the following and determine the valence number, group number, as well as the period. Okay, so looking at oxygen here, so what I'm going to do is, first off, let's just draw the nucleus. Then I'm going to go to my periodic table and locate oxygen. So oxygen is right here. Okay, so I can look at my atomic number and see, okay, the atomic number is 8, and the atomic number represents how many protons are in each atom of oxygen. So I'm going to write 8 protons. Now we need to figure out how many neutrons are in an atom of oxygen. So how we're going to do this is we're going to take our atomic mass, so that's 16, and then subtract our atomic number. So 16 minus 8, that's going to give us 8 neutrons. Let's try and draw a circle there. Okay, so I'm going to go 8 neutrons. All right, so now we have to represent our electrons. So going back to our periodic table, I notice that the group number is 16. Now, how many valence electrons are present is going to be equal to the last digit of the group number, which is going to be 6. So let's go back to our notes. I'm going to write group number 16. Okay, so I'm just following on what we're asked. And for the period, if I look back at my periodic table here, I notice, so oxygen's right here, I notice that oxygen is in the second period, or the second row of the periodic table. So I'm going to say, okay, second period. Why do I care about that? It's because the number of the period corresponds to how many energy levels you need to draw. So because it's in the second period, I'm going to draw 2 orbits, or 2 energy shells, whatever you want to call them. Okay. Now I'm going to pay attention to how many electrons each orbit can hold. So remember, the first orbit can only hold a maximum of 2 electrons. Okay. Now, how many electrons is this last shell, or this last orbit, going to hold? Well, if we think about this, okay, the amount of protons is equal to the amount of electrons. So we have 8 electrons. I just used up 2 electrons for the first orbit, so I'm going to go subtract 2. That leaves me with 6. Now the second orbit can hold at most 8 electrons. So great, all 6 of those electrons can fit in that second orbit. And now, since these 6 electrons are in the outermost shell, those are our valence electrons, which corresponds to the last digit of the group number. There's 6 valence electrons. Okay, so with the orbits, you don't have to draw the full circle if you're representing your diagram like this. You can if you really want to, but I find this is a bit easier to read. Let's talk about sodium. So I'll start out with my nucleus here, and let's see what group number and period sodium's in. So sodium, that's right here. So it's in group 1 and period 3. Okay, so what that means is I can expect that there's going to be 1 valence electron. So that's how many electrons are in the outermost shell, and there should be 3 orbits in my drawing. So let's write that out. So it's in group 1, third period. Okay, so 1, 2, Oh, I should squish this a bit closer together. 1, 2, 3. All right. So let's go back here. So sodium, the atomic number, there's 11 protons. So that represents, the atomic number again represents the amount of protons. And then for the amount of neutrons there, I'm going to round the atomic mass. So 23 to the nearest whole number. And then subtract the amount of protons. So that's going to give me 12 neutrons. So 11 protons, 12 neutrons. And then I'm going to start off my electron count, okay, by saying 11 electrons. The reason being is because for an atom of sodium, the amount of protons is equal to the amount of electrons. Okay, now remember that the first orbit can hold a maximum of 2 electrons, so I'm going to write 2 electrons. So I used up 2. So I have 8 electrons left. Now, the second orbit can only hold a maximum of 8 electrons, no more than 8. So I'm going to say 8 electrons here. So I used up 8, and I have 1 electron left, which is going to go in the outermost shell, and that 1 valence electron corresponds with our group number, or the last digit of our group number. So that's how you know you're correct. With calcium here, let's start out the same way. So we have our nucleus, which I'm going to draw a little bit bigger. Okay, and let's look at where calcium is. Well, let's get rid of this. All right, so calcium, I'm finding it right here. It's in group 2 and in the 4th period. So group 2. So that means I can expect 2 valence electrons, 4th period. So that means I should be drawing 4 shells, or orbits. 1, 2, 3, 4. Okay. So for the amount of protons and neutrons, let's go back to our periodic table. So the atomic number, that shows us how many protons. And then for the neutrons, I'm going to round the atomic mass to the nearest whole number. So 40 minus the amount of protons, 20. That's going to give us 20 neutrons. So let's go back and fill in our diagram. So we got 20 protons, 20 neutrons. All right, now for our electrons. Since we have 20 protons, because we're talking about an atom, that means we have 20 electrons. Now the maximum the first shell can hold, or the first orbit can hold, is 2. So I'm going to take away 2. So we have 18 left. The maximum amount of electrons that the second shell can hold is 8. So I'm going to subtract 8. So that leaves me with 10 electrons. The maximum amount that the third orbit can hold is 8. But we have 2 electrons left. Now, for what we've covered here, like it only talks about the maximum amount of electrons that the first 3 orbits can hold. But since how many electrons each orbit can hold is correlated to how many elements are in each row, if you look at the 4th row or the 4th period and you count it, so this row right here, you're going to count 18 electrons. So the 4th orbit can hold a maximum of 18 electrons. So there's plenty of room in the 4th orbit to hold those 2 electrons. Okay, so those 2 electrons are our valence electrons. It corresponds with the last digit of our group number. So that checks out. Moving on, there are some practice questions here. Please refer to the lesson guide to see which practice questions are assigned.